I think it's already recording, so I'm going to record this, just so people know. I think I'm going to wait till 1:30 and then I'll start the presentation. But we're just going to go over kind of building your own Homelab and kind of how to go about doing that if you haven't started. But yeah, there were some really, really good talks at B-Sides. They recorded all of them. So they have a YouTube channel, which I can pull up. Grab a link real quick. Right here, which I will put in the chat for people. But yeah, I think in a month or two, we'll have a lot of their talks uploaded, and you can kind of, a lot of them are worthwhile. There's a lot of fun ones. There's this one I attended who was from the person who's like one of the leaders at the UW cybersecurity club. And he went over kind of MAC address attacking, or I guess not like attacking, but like collecting information. And so essentially the NSA used this tactics. They still probably use this tactic. And it's basically you set up a bunch of like fake Wi-Fi networks up, and you put them, the way they did it was they put it over, international airports. They put them everywhere. And then they'd also put, you could, for example, cover a whole city, and then you could find out where in specifically they are going to in the city. The way that it works is, and the way that it was supposed to be fixed too, is your computer has a MAC address. Every device has a hardware MAC address. And then the OS kind of randomizes it from there. And in theory, it keeps you pretty safe, but the actual implementation of random MAC address doesn't really work that well. So if you leak your hardware address, or just by using context clues, even if it's still randomized, you can kind of guess where somebody was and how they were. And you don't even have to connect to the Wi-Fi network for it to get captured, because as long as that Wi-Fi server is running, they can just have a log and keep collecting all the MAC addresses that it sees. Because when you're walking around with your phone, it's always sending out requests. Even if you're connected to a Wi-Fi network, it's always saying, hey, is there a Wi-Fi network around? And what does it use for that? It uses a MAC address. So it's kind of a little bit scary, because I mean, if somebody was tracking you, they could, but yeah, that was a very fun talk. I recommend that one. I'll link to that one when it gets uploaded from B-Sides. But yeah, almost. I'm not. It's in Bellingham, isn't it?
Yeah.
Are you gonna go?
Yeah, okay.
That looks like a fun one. There's a lot of developers there, for sure.
A lot of infrastructure stuff.
It's at the Western Washington, or is it just like
Bellingham Technical College?
Okay.
Other side of Bellingham, still on the coast, not far.
If people wanted to join them, that's in the, I think somebody posted something in the general, right? All right. Well, it's 1:30. Go back to the PowerPoint. So, oh, I'm not sharing my screen. No, let me get that fixed. Sorry. There we go. Okay. Let's see if there's anybody in here. Hi. Oh. Hey, Sam.
Hello.
Let me know if you can hear me.
I can hear you.
Perfect. All right. Well, we're good to start. So what I want to cover today is a possible pathway to building a home lab at your house. And it pretty much revolves around just using any old hardware. It doesn't have to be a laptop, but I think it's fair to say that I think most people either have access to an old laptop or an old PC. If you don't, you can get one pretty cheap. Go on eBay. You can go to, there's RePC here in Seattle. They have lots of old hardware for very cheap. You can buy one for like $20. And yeah. So let me go to the next. Why would you want to build a home lab? Well, one, it's just a great tool to learn IT. Building and putting it up is just great, but there are some functional uses that you can get out of it that are very useful. The two primary ones, it's going to be, you can run a media server at home, provide it video files, audio files, pictures, and it can turn that into a Netflix-like interface, with several different tools. I'm just highlighting Jellyfin here because that's free and open source. I personally use Plex. You can also set up an SMB server, which is essentially a network share. So it's like a hard drive that you can access anywhere. You just have to log into it. And that is ridiculously useful. You can use it like a Google Drive. You can use it like a OneDrive. You don't have to worry about your data leaving your house. It's just going to be all there. And the best part, too, is you can set this up with a VPN, which means you don't actually have to be home to access any of this. As long as you have a VPN connection to your house, you can access all these services. So, and then another last one is you can remotely access a desktop computer or any kind of computer that you have at your house using this method. So requirements are that you have a 64-bit CPU. Most modern computers have this. If you have like, I would say around like 2007-ish, before then, you're going to maybe find some 32 bits. Not that you can't use them. It's going to be a little bit more hard. Compatibility is not going to be as much there because people have kind of gravitated away from that. So a modern CPU, essentially, but it doesn't have to be super powerful. You also want to have at least 2 GB of RAM. I think that's a pretty easy meet for most people. If you have a computer from the last decade, it is going to have at least 4 GB of RAM. I would be surprised if it didn't. And then lastly, you're going to want like a little tiny 4 GB USB flash drive to do this. So I'd recommend, if you have a low amount of RAM, that you move forward with Ubuntu Server, especially the LTS, which can be like the long-time service one. Is like an older version. It's works well. If you have more hardware, more RAM specifically, doesn't really matter what your CPU is, you would want to go with Proxmox. That is virtualization software. It is, you can do everything you can do with Ubuntu on it and more. So I recommend that if you have the resources to spend. So how do you get started? With your USB, you can plug it into your laptop. And there's 3 tools that you can use. You can either flash it with a tool called Ventoy. And basically what this does is it just turns your USB. You can still use your USB flash drive as normal. You just drag and drop files. But what you do here is from Ubuntu or Proxmox, you download an ISO file. And then you could put that ISO file directly on your flash drive. And then when you plug it in, we'll get to that part later, you can boot from that flash drive. And Ventor gives you a nice screen. Makes it really easy to manage a bunch of them. I highly recommend that. But if you just want to flash the USB flash drive just so it boots and doesn't do anything else, you can use Rufus or Belina Etcher. And it's really as simple as saying, I want to flash this USB drive, provided the ISO, and then click start, and then boom, it'll say you're all good. How do you boot from a USB flash drive? Don't know. I assume a lot of people maybe have tried this before. Maybe if you're building a computer, you probably have done this. The way that you do it, and these are very outdated images. I think a lot of laptops will have a BIOS that looks pretty similar to this. But basically what you do is it's going to be either like the delete key or a function key. You can just look this up, like the laptop name. How do I get to the BIOS? There may be some issues with this specifically. So if you have a Mac, for example, or I know Chromebooks have issues with this. Not that you can't flash a Chromebook or a Mac from a USB. It's just a more convoluted process. If it's a Windows computer, it's going to be pretty straightforward. It's going to be like this. You might find there's a password on there, which that is a whole another bag of worms, but hopefully it isn't, and you can just start doing this. And then so from there, you would have the flash drive in, you'd select that, and you'd put it at the top of the boot order, say, I want to boot from the flash drive first, and it kind of skips whatever OS is on there. Some recommendations, use Ethernet. Do not use Wi-Fi for your server. If you can plug it in directly back to the back of your router, that is the best option because it is way more reliable and safe, because Wi-Fi is not secure. Do not connect a server over Wi-Fi, just in general. If you're using a laptop, you can use, there's usually a BIOS setting that disables it from sleeping the computer when you close the lid. So this means that you can set up a server with a laptop and leave it closed, and it's going to run just fine. I recommend, if you're using Ubuntu, you disable LVM. This is going to make it much more difficult if, for whatever reason, that you need to recover files off a hard drive. It's just a headache. It's one button you press when you do an install, and it's going to save you a giant headache later. So once you have Ubuntu or Proxmox installed on your laptop or computer, What you will want to do first is you're going to want to reserve an IP address for that computer. And the way that you do this is you would log into your router. I don't have specific instructions for everybody because everybody has different routers, but usually what you would normally do, and I can kind of demonstrate this, is you pull up a terminal from your computer. You can do it from your laptop as long as you're on the same Wi-Fi, and you just do the IP config. You can go over to your Wi-Fi right here. You can see the default gateway is this. And so in this example, I can't get on the school internet, but if you were at home, it would look kind of more like 192.168.1.1. You would go to your browser and open that up, and it would give you a login screen. This is probably a time you'll figure out that maybe your router has a default password and you might want to change that. But yes, you would go there, and then it would kind of look similar to this. You would go to your DHCP settings, and then you would either select a specific device, or you would say, by doing the IP config on that Ubuntu server, you could find the IP and then just make sure that it's set to that device. And so the reason you'd want to do this is because you don't want, for example, if the Ubuntu server turns off and on again, it's going to get a new IP, which if you have a lot of services, you're usually kind of not hard coding, but you're writing in a lot of like, it belongs to this computer, it belongs to this computer. And so when it turns off and turns on, things will break. So generally just reserve it if you can. That makes it all way better. And so the last part I'll bring up is if you want to remotely access, because it's kind of cumbersome to have a monitor and keyboard plugged into a computer and just accessing it that way, I primarily recommend you can enable SSH. There's lots of tutorials on this. Ubuntu, when you're installing it, gives you the option to turn it on, and you just click a button, and then boom, you have SSH access. You basically just provide the username of the Ubuntu account you want to log into, or the Linux account you want to log into, provide the IP address, you type it out just like that on the screen, and then it'll ask, do you want to save this key? You give it the password, and you've got direct access to the shell of the computer, and you can do everything you can with the keyboard and mouse plugged in, but not having to. Now I'll move on to the next one. So the first service I'm highlighting is the Samba server. There's specific instructions here. I can share these with you guys. I highly recommend you can go through and do this. This is fine. And it'll work just fine as is. Basically, it's pretty simple. You just install. You make a directory where you want to share those files with people. You make sure that the user who's logged in is the owner of that folder. And then you set up the Samba config with some specific settings, which basically points to it and says that yes, you can write, and then disables that a guest can access it, which you don't want. And I highly recommend that you learn how to use Docker, which is going to be a more simple setup. You can use something called Docker Compose. I can get into that in later meetings if people are interested in how to cover Docker. If you can figure out how to do it, it's going to be a much cleaner install than directly installing on a computer, which is fine, but it's better to put it in container if you can. The second one I'm highlighting is Jellyfin, which is, you can use Plex, you can use Jellyfin, there's tons of different options. This one is much more straightforward. You run a command, it runs a script on your computer, it goes and installs it, and then you literally will have a web UI. So you go to your browser, you type in, it's port 8096, and you get access to the Jellyfin web UI. And then from there, you go ahead and configure it with whatever folders you want, shows, movies, and pictures, and it'll go ahead and just parse them for you. So you just drag and drop whatever you want in there, and it'll show up. The third thing I'm highlighting is Tailscale. I do recommend directly installing this on your computer. It's going to be working a lot better. I did highlight this in one of the previous meetings. I don't know how many people watched that, but Tailscale is a really easy to use VPN. The way that it works is you just have to have it installed on whatever computer you want, and they can see each other. It does all the work for you. It is really simple to set up. You just run a command, and boom, the other computer can see the other computer, and it works no matter what Wi-Fi network you are on. It can get around all the hoops and wires. You don't have to open up ports. You don't have to do any configuration. You just log into your Tailscale account from that computer, and boom, you're in. There's a couple options with Tailscale 2 that can make it a lot better. If you want, for example, to share IP from your home network to your computer, you can either have your traffic masked through your home network by using Tailscale, using an exit node, which basically says if you it wraps all of your internet traffic and says, if you want to go to Google, you have to go back home and then you can go to Google. So it'll come from your home IP address no matter where you are. It could be here, you could be, in another country, and it would always mask back to your house. Or you can do subnet sharing, which essentially just gives you all of the IP addresses from your home and gives them to your computer, no matter where you are. So you could be here and you can still access your IPs. You could log into your router, for example, from here. This is not so important. I pulled these slides from a video that I watched, and they kind of highlighted this feature that you can get on a lot of like Debian or Ubuntu-based systems where there's this package called Etherwake. And if you get the MAC address of whatever computer you want, and in the BIOS settings, you turn on something called Wake from LAN, you can basically run a command on your server and it can turn your computer on remotely. So it's really cool, kind of scary, but could be something fun to set up. The last point I kind of want to bring up is be careful when you're port forwarding. Once you get a server, you're going to start running a couple services. Maybe you have a website, maybe you do some game servers, whatever you want. Don't port forward stuff like your SSH. Don't port forward a website. There's much easier and better ways to get it out to the internet than just providing that. You can do this. It is not like you're going to immediately get attacked, but it's just a hole in your network that you don't really need if you don't need it there. Like if you were running a Minecraft server, for example, you're most likely going to be fine. I've done that for decades, and I've not gotten like attacked by people through that. People will try to do stuff, but they're not really going to get that far unless your Minecraft server is like vulnerable and somebody can remotely execute code on it. But yeah, that's what I brought up. I borrowed it from this YouTube video, which I recommend if you want to watch. He does cover in detail how to set this up. All I covers a lot of what I talked about. And yeah, I'm kind of opening the floor for questions. Anybody curious about setting up a home lab for themselves or? No.
Yes.
Yeah, I'll share the slides with everybody. I'll make sure it gets put in the chat. Right now, let me pull up what I've been working on recently. I've installed something called Waza, and let's see if I can find where it is. I think I got it. Which is software called SIEM software. And the way that it works is it pretty much, I gotta log in. You install it on whatever on the computers that you want, and what it does is it takes all of the logs from those computers and it feeds it to this Waza server. And then from that Waza server, I can view all of my logs from all of my computers in one place. And it automatically highlights things that it may see as like, this is problematic. Like, for example, if somebody were to log into my computer, it would let me know. It would say, hey, there was a login attempt here and it failed or it got successful. Or it could be like somebody installed software on your computer and it would show you in your log and say, hey, this Windows computer was trying to install this or whatever. Or, the UAC, when you get the administrator pop up and it says, do you approve of this? Yes or no? It'll tell you, hey, somebody said yes, or somebody tried to do it and they couldn't do it. And so it's used widely across cybersecurity field. It is the primary tool that if you're working in incident response, you would use. So it's a great tool to set up. Again, I thought it would be way harder to set up. It's actually really simple. You run a command, it installs it, and then for every computer, it gives you a little walkthrough. You say, oh, it's a Windows computer, and then it gives you a command, and you just paste it in the terminal, and it installs the software and hooks up to the server. But that's what I've been working on. I host several game servers. Ooh, I am trying to log into the wrong account. Yeah.
Is it its own end-to-end bundled experience, or does it nicely interact with like Loki and Griffon and other similar log tools?
I haven't gotten super far into the configuration. I know it has a lot of integration with different tools. So I don't know about Loki and Grafana. I know, let me see. There's a couple here that it lists, but yeah. I don't know off the top of my head, unfortunately, but you can see here it gives you a lot of information. It can even give you regulatory compliance information. So like, how are you storing information and does it meet the specs? This is meant for enterprise, obviously. It's not meant for just doing it at home. But I can, yeah, if I select an agent, my computer, yeah, it'll tell me, hey, there's some vulnerabilities. And so it can do scans on your computer and it can say, oh, there's this CVE. You're running software that's outdated and somebody can use this attack against you. And it would highlight it here and it scans your computer. It's like a more advanced version of Windows security. Windows security does a good job, but like this will give you a really, really deep look into it. And there's even some other software that I've been using called Run Zero. Might have to log into. Yeah, sorry.
Are all these free?
Yes, they're free. They all have community editions. Waza is open source. There's other options you can go with. This is not the only one. Elk Stack, I'm sure if you've done classes, probably have touched base with that, or maybe like slightly covered it. Man, it's making me do 2FA. Everybody loves that. I'm sorry, what was the question somebody asked? I kind of lost my train of thought. What was I doing with my home lab? I also have a Proxmox server running. Oh, I don't know the IP. I think I can guess. Yes, that was that one. So, and I'm gonna pull this away. These are separate computers that I have running Proxmox, which from there I can run virtual machines inside of. And so I will log in real quick. Sorry.
We answer that. Well, using Proxmox, how consuming is it to run to VMware?
I use it because it's free. VMware you have to pay for. I think there are options to get it for free, VMware. I imagine VMware is like more mature because it's enterprise software. I mean, Proxmox is too, but VMware is more common. That's the more like industry standard. So if you were to, for example, ask a lot of the teachers here, you know, what do they use it in their job? They're probably going to say VMware. I think it's really hard to get a hold on. I think it is possible. I don't know the comparison is like, is it more efficient? Is it not? The overhead of actual Proxmox is not that high. So you do get a lot of your resources. Like the reason why I said 8 gigabytes is because you can have probably like 3 VMs running with like 2 gigabytes each. And then you just really only need like a couple gigabytes for your Proxmox. It's pretty lightweight in my experience. It is not logging in. Try one more time.
Assuming you are cybersecurity.
Mhm.
So doing projects, how would you compare using setting up your own lab to using silent range so with the projects that are already set up?
Well, you get more versatility. So you can create there's lots of options for buying really, really old hardware. You can set up switches and routers physically, which you're going to get a lot clearer idea of how that looks and works than if you were to virtualize it. You can use software, which I do have installed on this Proxmox node. I can't log into it right now, so I'm gonna have to come back to that later. But it lets you fully automate a creation of a network. So you can say, you put it out to spec, and there's lots of templates online. It's called Ludus is the software. And it uses Proxmox. And you can just put it there and it can say, oh, make an Active Directory, make a couple users, make a couple computers that are connected to this Active Directory, and it spins it all up. You don't have to like go through and configure it. It just does it for you and makes that whole thing there. This is extremely useful as a learning tool, not only because you get an environment, which is genuine, it's like real hardware. Well, it's virtualized, but in all intents and purposes, it's going to work exactly how it would if it was installed on real hardware. This tool I haven't got to mess with a ton. I am going to be bringing it here to the club. So you will get hands-on with this if you do show up. I'm bringing a router. I'm bringing the computer that's running this in here, and I'm going to hook it up right over here. And you can bring a laptop and connect directly to it. And so the Proxmox server I'm logging into is actually that device that I'm bringing here. But yeah, I'll set up like a whole Active Directory. People will get access to it. We can show how it works. We can show a tool called Bloodhound and how would you scan an Active Directory as an attacker, get a whole map and everything. The thing I'm going to cover that like I'm so working out the setup for this, but I'm actually going to bring a real laptop in here, and I'm going to install something or an exploit. I'm not going to install it on there, but I'm going to install Windows 7, which is exploitable with something called Eternal Blue, and it is going to be a primary purpose to show you like don't connect Windows 7 to the internet, and here's why. And we're going to boot to root. We're going to turn the laptop on in its default state, and we're going to use the little attack box, and we're going to go get access to the desktop. And I'll show you how to do it. And it's one of, in my experience, the easiest hacks you can do, because Windows 7 is really vulnerable. And you just run a couple commands, and you get direct access to the desktop. So, but yes, I kind of strayed far away from your question.
It's pretty cool.
I'm excited. I'm excited. It is you just by putting stuff together, you do learn a ton, because I think once you get something physical to mess with, it's a little more meaningful than the cyber range. Not that you can't learn with the cyber range, you can, but it's distant. It's a virtual thing. It's way out there. You log into a website. It's not really yours. It's owned by, Western Washington. I don't know who heads that, but so yes, you still can learn, but if you physically make something, you own it. And so that's your property. You can do whatever you want with it. You can install whatever you want with it. You can use it for whatever purposes you want. And once you have ownership of something like that and you want to build something out and you see the like purpose, like the reason why I brought up a media server is once you set something like that up, you can start sharing with other people and they'll see the value immediately. Because like, I'm not gonna get too into the weeds here because it can get kind of dicey, and I'm recording this. But you can use that in a pretty cool way, I would say. And those are just like 3 things that I brought up. There's tons of stuff you can run locally. You could run your own website, for example, and then share that with the internet. And then people could go, you could host your own website, not have to pay for it or anything like that. Did you have a question?
Well, I'm going to share specifically with the media server that I'm trying to set up. It's going to house as cloud storage the 8 terabytes of movies, music, TV shows, comics, books that I collected from the 5 years I was in the military, to be able to stream that by using an Active Directory. So that way I can have to specifically me, my partner, and my partner's parents have their own accounts to access that information, as well as have it act as cloud storage on top of that with the VPN. So that way people can access that anywhere, anytime.
Yeah, I highly recommend it. Once you get in that rabbit hole, it is definitely, you learn a lot. And it's one of those things where you get a product out of it. And it's immediately apparent why it's cool. I am not condoning anything. I'm not going to condone doing illegal activity with it, but it's a good learning tool. So there's this software, this other software that I set up called Run Zero. It is enterprise software. It does have a trial, but once it expires, you get a community version. And the way that it works is it is essentially like an automated Nmap tool, and it goes ahead and parse all of the data it collects into a very easy and readable format. And you can even install, if you install Chrome, for example, on the same device that's running this, you can actually have it go visit the websites located on your network. So it could go to the login of the router page and take a screenshot, and then it shows you here. I didn't do it properly. But what's really cool is it can actually show you vulnerabilities. And there was something that I didn't know was on my network that was running, and it was there. And I was like, now that I know that it was there, it kind of scared me because it was like default password, and there's this something called an IPMI. And so on certain motherboards, I have a motherboard from a server, and on certain motherboards, they actually have two computers running. They'll have the actual computer, the one using the CPU, and they'll have a tiny computer that sits above the other computer and is always running as long as it's connected to the power. And that tiny computer is called an IPMI, or there's a bunch of different names depending what server manufacturer you're going for. But it hosts a website. And in that website, you can log in and you get direct access to the host, the computer down, lower down. You can see the desktop, you can send commands to it, you can turn it on and off. Not super great to have open. So I didn't know that it existed on my network until I ran this scan, because I had originally thought that I had turned it off in the settings. Don't run this service, please. But it was, and it highlighted here for me, or not these ones. Let me go to, yes, this one. So it highlighted the IPMI, and it said, it even hosted the vulnerabilities. It was like, yep, it's pretty vulnerable to these. And you can see the amount of CVEs that this IPMI has. It is not great. So direct SSH access to it, which means you have direct access to everything on that computer. Kind of scary, but running software like this will tell you, like, even with, iOS stuff or Windows stuff, is it outdated? Is it vulnerable? What type of devices do you have running on your network? And so it can go and tell you and give you pretty detailed information. This is, again, free, easy to set up. You just install it on it, and then you go to the console, and you just run a scan right over here, and yeah, let's see. We can go do another scan. You can make templates. You can do more detailed stuff. You can do this by hand by using Nmap, for example. This is totally possible, but services like this provide you in a nice, usable, readable format. I'm going to be sharing both of these websites for people who are interested. Waza and RunZero. They're straightforward to set up. There are a lot of alternatives. For example, you could run an elk stack. That is open source and free. That is a lot of work to do. It's enterprise software, which means you're configuring a lot of it by hand, because you usually get paid to do that. But I recommend learning how to use the software, because if you go work in cybersecurity, pretty much anywhere you go, you're going to be interacting with software like this. Like, this is pretty standard across the industry. A lot of the entry-level jobs, if you're working specifically in the degree of cyber and not just like as an IT help desk, is going to be as an incident responder, and you're going to need to know how to use these tools. Like, you're going to need to know how to, like, make a dashboard or graphs with the information that you get, and kind of parse it. How do you take all of these logs and turn them into something useful, where it's like, hey, I know that something was happening here. It's kind of, off. There's other things too. There's lots of ways to virtualize stuff, and the thing is running Windows is great, but it's hard to run a lot of software for Linux on it. It's possible, but it's just a lot harder. But having a dedicated machine that is Linux is really, really nice. Having it directly installed on the hardware is a great way to learn. And so, yeah, I'm curious if anybody else has more questions. I can kind of, I didn't have an extended list of what I have installed. I have a lot of stuff running and a lot of stuff that I could share, but I don't really want to share when it's recorded. So maybe I'll share it when it's not recorded. But yes, anybody have questions? Yeah.
You mentioned earlier not to go to a web server directly. What would you do with that?
I would use a service called Cloudflare tunneling. Oh my God, please get out of the way. There we go. If you go to Cloudflare, let me see, it might have me log in. Yeah, probably. The way that it works is that you install this tunneling software on your host computer or network. And then from there, you basically point to an IP address and port and say, can you share this, please? And then as long as you have the caveat here, and this is true for a lot of things you're going to buy on the web, you're going to have to own a domain. You're going to have to own like so-and-such.xyz or whatever. And From there, you provide Cloudflare access. You can either buy a domain from Cloudflare, which I recommend because you don't have to do all the config work, or if you have a domain somewhere else, you change the name servers to Cloudflare. And then from there, you use their zero trust is what it's called. And there's lots of different things you can do with it. Not only can you just make it public to the internet without having to port forward, you can lock it down with SSO. You can hook it up with Google, GitHub, and say, if you want to access website, you have to log into Google first. And on top of that, your email has to match this. So you're going to a trusted provider first. They verify, yeah, this person logged into this email, it's genuinely them. And then they forward you onto the website, which is like way more secure to like, expose your network that way than it is just to like port forward and say, well, I got port 80 open. You can go visit my website, which you can. That's fine. People have done that for years, but it's not safe. Yeah.
Preserving an IP address from the TCP pool, is there any scenario where it would interfere with other devices aside from static overlap?
So there's two ways that you could achieve the like static IP, which you could just set on your device. On Linux, it's really easy. You just go to the etc network interfaces file, you edit it, and you can manually type in, a static IP. You're set to this, and you're just, whenever you communicate on the network, you're just going to say I'm this. You're not going to go ask, what's my IP? The reason why you would want to do a DHCP static IP is to avoid specifically what you're talking about, where you have that static overlap. Because when you are a static IP and you're connected to the network, a lot of routers are smart and they'll know not to do that, but not everyone is. Not all routers are going to do that. And so what can happen is you can get an overlap, which can cause some issues on your network. Your device stops working, and then you have to go manually plug into it and change the IP, which is, it's not that bad. It can be a headache, and especially if you don't know what's going on, it can be very confusing. But the idea is when you use your router and you say, this IP is secure, like, don't change it, leave it the way it is, this device, what it does is it says this MAC address, whenever it's connected to the network, and I was talking about this earlier, but every computer has a hardware MAC address, and when you connect to a network, it uses that hardware MAC address, and that MAC address doesn't change, it's static. So no matter what network you connect to, it sees that that's your MAC address. And so the whole thing with the DHCP is, even if your computer turns off and turns on again, it sees the MAC address and it's like, oh, I already know what you're going to be, and it sets it to that IP. And once it has that like log in the DHCP server, it's never going to lease that out. It's never going to like overlap, because it knows that like, hey, this IP is reserved. And so that's why you want to do that over directly setting an IP on a device. But yeah, hopefully that answers your question.
I tried to set up server once, and I got the server running and functioning, but
You weren't able to share it with outside?
yeah, I could connect to the server on my PC, and then I was able to connect to the server on my PC, right?
Mm-hmm. But anybody outside of like on the same network couldn't connect?
I'm pretty sure. Yeah. Same Wi-Fi.
Yeah, the way that would work, and you can see here, I've shared my subnet, and so I'm directly connecting. So for example, if I set up a Minecraft server and I wanted other people to be able to join, I would give them, if they were on the same internet as me, I'd just go to my terminal and I'd do that IP config, and I'd grab my IP. Oh, well, here's my IP, and I'd share that with them. I'd say, go connect, and then basically they'd go to Minecraft, put that in the IP, and they'd be able to connect. But they'd have to be on the same network as me, same Wi-Fi, same router, same everything. That would work. But if you were trying to say, my friend in their house, come connect to my Minecraft server, well, that wouldn't work. And the reason that doesn't work is because of your firewall, which is on your router, and then you have to pay for it. You have to pay for it?
I think the problem I ran into outside of my network, that I had to pay for an IP somewhere along the lines that other people could come in.
Every computer has an IP. The why you would pay for an IP from your ISP is that generally most internet plans don't provide something called a static public IP. So, but every computer has a public IP, which doesn't mean you have to pay for it. It just means that your IP is going to change pretty quickly. So like, it depends, if your router resets, it obviously changes the IP, or your modem more likely. There's a kind of time period, I think it's about a month. So it's pretty long. It's not super quick, but your IP will then change to something new. So I don't know what it is for internet plans because I have a pretty long lasting IP, but every internet kind of has a random public IP. And the way that you can get a public IP is actually really funny. There's this web, ICANN has IP, and it'll just spit back what your public IP is. And so that's the public IP of this network address. So here at the school, that's the public IP. And so I'm going to share all this with people. But yes, ICANN has IP. Really fun because you can just curl that in a terminal and it'll spit the same thing out. What you would do is you would port forward your 25565, which is for Minecraft, and then you'd give that to somebody. So as long as your router says 25565 is allowed to go forward and backwards, we'll just give them that IP and they can connect to your Minecraft server, or in theory, they should be able to. I haven't experienced it, but I use Comcast, so I don't know if it depends. Yeah, I would say that like in theory, this is how it's supposed to work, but in practice, it might not work. You may have to reach out to your ISP. There are alternatives around this. For example, you can use tunneling. You can use Cloudflare tunneling. There's this service called playit.gg, which is you can use for free. It works exactly the same as Cloudflare tunneling. You would make an account, you install the forwarder, basically lives on your network. You don't even have to port forward on your router, and then it creates a domain and says you can join to this server. So that's another method. And then the last method would be actually setting up a VPN and then giving people access to that, which would also work. So
what I was asking about reservation. I got server to work, but the TV remotes decided to stop functioning. I don't know if it was because I reserved an IP wrong or whatever. Probably not. But we had to call the TV company and to readdress them because of course it's proprietary. You can't get in on your own. Save on money.
did you go into your router settings and then change the dynamic IP or the DHCP settings? Is that what you did specifically? And then it goofed everything up? Was it your TV itself that stopped connecting to the internet?
No, TV, it was just the remotes.
Oh,
But we were still able to control the TV from the remote apps on our phones.
so in my experience, a lot of TV remotes and even still like newer ones still use something called IR, which is like infrared. You press a button on your remote. For example, if you use your phone and then you point it at the front of your remote, you can actually see the light because your camera can pick up IR. You can't see it, but there's a receiver on your TV. A lot of even newer TVs will have this little black piece of plastic that sticks at the bottom, and you point and click, and then it registers your inputs because it sees the little lights coming from your remote. So I don't know what happened specifically in your case, but that's the way that a lot of TV remotes connected. Smart TVs don't use that. They use Bluetooth, but again, I don't know how a DHCP configuration would mess with that. So, but it's possible. I'm not going to say it isn't.
I can't remember. If both the server and my laptop were able to see each other, or it's one side was, because I remember some of the steps going right before hitting the wall. I just saw it, like huge wire shark. It was very fun learning experience. Being able to set filters to get all the noise out of the way and see only what was going from my laptop to the IP I was trying to connect to. On the
Still couldn't.
I think yes, it would see it.
So
it would deny.
what can happen sometimes is Mike or Windows has a firewall. It's called the I gotta pull up control panel. There we go. And I'll go ahead and navigate it to it for y'all. So it's going to be under system and security, and it's going to be this Windows Defender firewall. And so you can turn the firewall off completely. And then in theory, you should be able to connect. Sometimes, I don't know. Sometimes you got to do a little debugging. There may be like specific reasons, but this may prevent in some cases. Essentially, the firewall is more or less works exactly the same as a firewall on your router, but it's running locally on your computer. And so a lot of programs will like pre-configure themselves just to work. So example, a lot of anti-cheat will do this. It'll just open a port and it runs a script. And that's when you do the UAC and it says, you say, yeah, it goes and makes a firewall hole for you. There's tons of programs that do this. So like, it's not super uncommon, but for example, if you're setting something yourself, it doesn't do that for you. And you may run into the issue of it's hitting the firewall and Windows is just not letting it exit. So for example, on the server, it might do that. Or generally when you're connecting to something, it doesn't matter. Like you're not going to hit a firewall, but sometimes it might. But yeah, feel like I kind of got a little bit sidetracked, but I think that's more or less. I don't know if I kind of answered your question or not. It's kind of a. Anybody else have questions about Homelabs, like, or suggestions for uses? Or I know, Visma, you got a pretty cool use for Homelab that I haven't set up personally. But your plan for it was pretty cool.
Plans. It's always planning. You find something new, place it. I'm trying to get Proxmox up, and I've got like a resolution, so I can see that it's up. I just can't do the half of the screen.
You can change the display. In VirtualBox, you should be able to change the display settings, and then
I've been trying to like navigate that. I haven't found anything yet.
You can run it in a virtual machine on your computer, but I do recommend actually installing it on hardware.
When I get the server or something, I'll install it. I can't install Proxmox.
I would recommend just setting up Ubuntu or like Kali, so if I'm going to have in a VM, or use WSL, which you have on your computer. So those are all fun options that you can do on your laptop. What else? There was one other thing I wanted to talk about, but I can't remember now. Oh, it was what you were going to do, which I was going to share with other people, which is a Home Assistant. So this is open source software you can install. And if you have smart devices installed on your network, you can set them up with this. It's an all-in-one app that can connect to a bunch of different stuff. So if you have like a smart light bulb, for example, it would connect to this. Or Visma's trying to set up cameras. You can buy little tiny IP cameras and then you can hook them up to this. So there's lots of cool things you can do. And then you all have it locally managed from that server. So you would install this on your server. And then from there, you would just connect everything to that. And it would manage all of that for you. Yeah, there's tons of different options. There's lots of fun things you can set up on your home network. I'm going to stop recording and I can show you some other stuff that I've set up. Yeah, I think, let's see. Sam, did you have any questions or?
I don't, thank you.
Cool. All right. Yeah. I'm gonna stop sharing. Oh, I'm gonna keep sharing actually, and then I am going to stop recording. There we go. All right.